Today we are going to discuss a very simple topic in organic chemistry. It is a kind of recapitulation about 80% and 20% extra we understand in today's discussion. So today we are going to understand structural formula for organic molecules. Okay, for everything formula is required, like that here also we require formula. Which formula? Formula for the chemicals. Okay, so for a formula, sometimes we draw uh, in the expanded form. Okay, that is called structural form. Or if you don't have time, we write in the condensed form. That is called condensed structural formula. Okay, so we write still condensed form. That is called molecular formula. Okay, so there are many formulae for a particular molecule. Depend upon the requirement, we write a molecular formula in the condensed form or in the structural form. So it when the situation demands, then only we can write. Otherwise, normally for everyday discussion, we go for the molecular formula. But today we are going to understand structural formula for some selected organic and some selected simple organic molecules. So I think uh, you understood which topic we are going to discuss. So today's topic of discussion is to draw structural formulae for some simple organic molecules. So I welcome you all for the today's session on structural formulae. Yeah, CH3, CH2, 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 CH2. 1, 2, 3, 4, 5. This is pentane. This is pentane. Please recall 10th class. But this is little expanded form. So around C there are 3 hydrogen, around this 3 2, around this 3 2 2 and 3. So this is little expanded form. Okay, this is called structural formula. So when I draw structural formula in this way, so instead of writing in this way, if I write this is called a CH3, C and 3 hydrogen CH3, CH3. Second is what? C with the 2 hydrogen CH2. This is CH2. This is CH2. Last one is C with 3 hydrogen CH3. So instead of writing in this way, I write in this way CH3, CH2, 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 CH3. So this is called we are condensing the formula. That's why it is called what? Condensed formula. This is expanded or structural formula. But one more way is there. One more way of drawing structural formula for pentane. See here. This is called line angle formula. So using line, using angle, some angle is made here. So here we don't mention any angle in terms of degrees. Just angle is made. Okay, that is called line angle formula or bond line formula. Bond is shown as a line. Bond is shown as a line, so it is called as a bond line formula. See, end point always means CH3. This is end point CH3. So this is CH3. In between, no, in between this is called point. This is the one bond here, and this is the in between carbon. So this in between carbon means a CH2. Okay, and where there is no connection, end point, it is taken as CH3. This we take it as CH2. Again here in between, okay, CH2, in between CH2, end point CH3. So these two end points are CH3, in between are CH2. So this is called what? CH3, CH2, 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 CH3. If you draw in this way, it is called bond line formula. So for every molecule, in three way we write. One way structural formula, other way condensed formula, other way bond line formula. So for every molecule, in which way he demands, that way you have to write down in the examination. Okay, right. CH3, CH2, CH, CH3 is OH. This is called butanol. Now time being, let us not worry about the name. For naming ceremony, separate what discussion is required. Maybe 5 to 7 days we require, almost 1 week. So to understand all the rules for naming, so timing, let us not worry about the name. I am only telling. So how it is, why it is called as that name only, we will discuss in our later classes. Okay, this is called butanol. Okay, expanded form, expanded here. So this is what CH3 in between CH2. This was CH2. Okay, because one extra attachment is there here, so one H is removed, in place of one H, OH is there. So it is called CHOH. Okay, now again end point CH3. This is propanone, acetone. Okay, so end point CH3, end point CH3. Here, actually, it is called CH2. Okay, but here double bond is created. So we have to remove both hydrogen for the double bond. So that's why it is called C only. So depend upon the number of H available, we take it as a CH2 or CHR, no hydrogen, or it is the only double bond here. So CH2, C double bond O, CH, sorry, CH3, C double bond O, CH3. Okay, bond line. Now this we apply for the one closed structure, ring structure. Cyclopropane, propane is 3 in cyclic form, 3 in cyclic form, 3 in the cyclic form, ring structure. CH2, 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 but is simple way, triangle. Okay, bond line. Cyclobutane, butane in cyclic form, bond line. Cyclopentane, 5 carbon pentane in cyclic form, expanded, bond line. Cyclohexane, 6 carbon atom, not open chain, it is a closed chain, expanded. This is what ring structure, closed structure, bond line. Okay, please practice. Okay, after understanding, after going through the slide, you practice with the in a rough notebook. So in 1 or 2 days it becomes very easy. See many more examples for structural, condensed and bond line. Okay, structural, condensed, bond line, right? Variety of examples, variety, very. See, organic chemistry is very beautiful. Okay, only thing is, keep in mind catenation property of the carbon, and carbon is always a tetravalent. Around every carbon you will have 4 bond. Okay, you see one example, 1 bond, 2nd bond, 3rd bond, 4 bond around this carbon. Now around this carbon, 1 bond, 2nd bond, 3rd bond, 4th bond. So everywhere carbon is tetravalent. So this point to keep in the mind, right? So all these are I have given for you to practice, understand it. Okay, understand it. Okay, this is, you see something different here. What is this? CS3, C on the top CS3, at the bottom OH link is there, branching is there, and CS3. So end points are CS3 only. So this is one end point CS3. This is another point CS3 on the top end point CS3. In between, it is only C. Why? Already this side one C is there, one C is there, one C is there, and this is having an extra link with OH. So this is only C. Okay, like that. Okay, right. Condensed structural bond line. Now see butene. Butene, CH2 double bond CH, CH2, CH3. One more butene, different butene, only change in the position of double bond here. Okay, butene. Why 2 butene? Why 1 butene afterwards? Not now. Okay, so this is what CH3, CH2. Here due to the creation of one double bond CH. Okay, now here CH2. Why CH2 here? End point is usually CH3. But due to double bond, one H is removed, so CH2. But here also one bond, here also double bond, so CH2 will not come here. It is CH only. Okay, right. So it only comes by practice. End point CH3, CH2, CH2, third carbon atom, CH3, CH2, CH2, CH3. So one sample I have taken as just one, understand which is carbon 1, which is carbon 2, which is carbon 3. Hexane, CH3, CH2, 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 CH3, no double bond straight away. In the same way, dodecane. Okay. You see here, these are called isomers of pentane, 10th class. Isomers of pentane. Normal pentane, straight line. CS3, CH2, 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 CH3. Isopentane, one branching here. So this is what CH3. This was CH2, but due to this one extra what? CH here. Okay. CH2, CH3. This is neopentane, CH3, CH3. Only C here. Why? Two branching is there here. This is CH3, this is CH3. That is what? CH3, C, CH3, CH3, and CH3. Please write down. Same normal pentane and the isopentane I have repeated here. So branching is here. So please practice so that bond line becomes very easy. Sometimes he will ask for the 1 mark. So you have to be ready because every mark is very important for us. So we have to study for 100%. So our main aim is to score out of out. So with this, today we conclude the bond line and tomorrow we go for the interesting area of organic chemistry. Till then, bye and thank you, my dear students.